Working on 6.8 homework now. The first question is about someone who kicks a soccer ball from the ground. So that tells us h naught equals 0 with an initial velocity of 12 meters per second. So that is v naught at an angle of cosine 40. So that's theta. And the first thing that asked is for what is the horizontal distance the ball goes after 1.5 seconds. So horizontal distance formula is our x formula. We have x is equal to t v naught cosine theta. So that would be 1.5, that's t. Let's put the unit so you can see. That's 1.5 seconds times the velocity, initial velocity is 12 meters per second. This is over 1. Times the cosine of 40 degrees. And you'll see the seconds cross out and we get meters. So if you punch that into your calculator, you get x equals 13.79 meters. So that was part A. Part B talks about the vertical distance after 1.5 seconds. So that would be our y equation. So if you try to remember that, it's y equals t v naught sine theta, very similar to x, but then it has to factor in gravity. So minus 1/2 gt squared. And we're doing meters per second, so g is equal to 9.8. And so let's stick everything in there for this equation. So you would get y equals 1.5 times 12 times the sine of 40 degrees minus 4.9, that's half of g, times t squared, which would be 1.5 squared. And if you put that into your calculator, you'll get 0.55 meters. All right, so that's how high it was and how far it went after 1.5 seconds. Number 2 is about Janice, who's returning a tennis volley from an initial height of 3.5 feet, so that's h naught, at an angle of 15 degrees, that's theta, and initial velocity of 50 feet per second, so that's v naught. And we know that gravity is going to be 32 feet per second because it's in the velocity is in feet per second. So it asks for the maximum vertical height. What is the maximum vertical height? And to do this question, if I draw a little picture, here's her volley, okay? And they want to know, when does this maximum height occur? When? And that means the x value. And no, I guess it doesn't ask when, it asks what. But in order to get the y, we have to figure out when it was and then stick it into our vertical distance formula. So do you remember how we find the x coordinate of a quadratic? Remember, it is the opposite of b over 2a. So if we write our equation, first, we have to do that in order to see what b and 2a are. We have y equals, and then it's t, and then it's v naught, which is 50, and then it's sine of 15 degrees, minus 1/2 g, which is 16, t squared, plus h naught, which is 3.5. Okay, now does this look like a t squared, and this is a t, and this is the constant? So I'm going to put it in the order you're used to seeing to pull off a and b. But if you don't like to do that each time, you can tell this is b, right? And this is a, and it has this negative in front of it, and this is c. But just so you see what we're doing, this is negative 16t squared plus 50t sine 15 degrees plus 3.5. So when I take the opposite of b, that would be negative, we're solving for time, right? Because time is like your x in this case. So t is equal to the opposite of b, which would be negative 50 t sine 15 degrees. Not the t, though, remember? You don't use the variable when you're pulling off the coefficients. Negative 50 sine 15 degrees over 2 times a. So that would be negative 16 times 2, which is negative 32. So if you punch that into your calculator, you should get 0.40. We'll just go to 2 decimal places with this. So that's the time that it took to reach the tallest point. And if you want to know the tallest point, you now put time into y. So you go back here and you say y equals negative 16 times 0.40 squared plus 50 times 0.4 times sine of 15 degrees plus 3.5. So that is equal to 6.116. So if we're rounding, you would say 6.12 feet. Okay, that's the answer to part A. Let's go on to part B. So for part B, it's just asking you to find the horizontal distance, which is our x equation, at the time it reached the maximum height. And we already know, we figured that out from part A, that the time was equal to 0.4 when it reached the maximum height. So let's put that into our x equation. X equals 0.4 times the original velocity, that was 50 feet per second, times the cosine of 15 degrees. So if you put that into your calculator, you get 19.3185. So if we're going to round that, we'll say 19.32 feet. So if you want like a picture of what happened, okay, here we go. If this is time and this is height, at the height, it was the last answer, 6.12 feet. And the other equation, if time went by, you were looking at how far did it go after 0.4 seconds, and it went 19.32 feet. Okay, so that was number 1 and number 2 for your homework.